Okay, so rational equations are basically just when you have a fraction equal to another fraction. And you've seen this before because when you were in grade 9, especially at this school, we used to do proportions. Remember when we were learning percent and ratio rates and all that stuff? I know this because my grade 9 class is doing it right now. So this is a concept you are familiar with. I'll give you an easy example. When you had something like x over 6 is equal to 2 over 3. The way you could solve this is you can multiply these two together to give you 3x. You can multiply these two together to give you 12. And then you can solve for x, which is just going to be a 4. So this is called cross multiplication. And we're basically going to do the same thing, except this time we're going to have larger numbers and binomials and things like that. 4. That's an equal sign. Not a subtraction sign. No. Okay, so here are some notes. What we're going to do is we're going to set up a proportion like AB is equal to C over D. We're going to cross multiply. We're going to solve the equation. And then we're going to check for extraneous solutions, which I hope to explain today. So let's try question number 1. We're going to go ahead and cross multiply. And when we do that, we have to remember to keep the binomials in brackets. So really what's going to happen is it's going to be 18 bracket x plus 3 is equal to 6 bracket x minus 1. And then from here, this is like good old grade 9 math. We're going to distribute the 18. What is that, 54? This will be 6x minus 6. I move the 6x to the other side, so 18 take away 6 is just going to be 12x. And then I'll move the 54 to the other side, so negative 6 minus 54 is just negative 60. And so x is just going to be equal to negative 5. We should also be writing our restrictions. I know the question won't ask for it, but if it did, I think you guys are pretty good at this now. X cannot equal to 1 and x cannot equal to negative 3. I'll just change the order of it though. So it'll be x cannot equal to negative 3 and 1, because that's what's going to make both of those or either one of those undefined. Yeah. So after a discussion, we decided we're not going to be writing restrictions because it doesn't make sense. Yes. Because there's only one value for x in this question, and it's equal to negative 5. So obviously, it's not going to be equal to anything else. All right, we're going to do this one more time, except a little bit slower. Let's go ahead and skip to question number 5. Okay, so what we're going to be doing is we are going to cross multiply. So we're going to multiply these two together, and we're going to multiply these two together. And when we do that, we have to remember every binomial is going to stay with itself. So we're going to basically put brackets around it. So when we do the first part, we're going to go w times w plus 1, w plus 7. Do you see where I got those from? Yeah. And then we're going to multiply the other two, which is going to be 5 times w plus 3. Now we're going to distribute the numbers in front of the bracket. So we're going to get w squared plus 7w. And on the other side, we're going to get 5w plus 15. Now this is interesting because we actually end up getting something where you can't just move the x's to one side and solve. But we know how to solve a question like this. I'm actually going to move everything over to one side. So I'm going to get w squared. 7w minus 5w is just 2w. And then when I move the 15 over, it's going to become negative 15. And how do I solve for w when it's a trinomial? I'm going to factor it, and then each one of those brackets gives me my value for w. So we're going to go ahead and factor this simple trinomial. So when you factor something, how do you solve for W? We just take each one. Remember how we were doing restrictions? It's the same thing, but now we're actually saying that's what W equals. So our final answer is just going to be W equals -5 and W equals 3. Okay? When it has a square. Because you can't isolate for W in this question. There are too many W's around. So in that case, you know you have to factor. Yep. Correct. Yeah. Marju? No, no. Sarah? I like question 11 because when you cross multiply, you're actually going to get a whole bunch of brackets that you're going to have to FOIL. So for this question, I would get 3y minus 4 times y plus 2 is equal to y minus 2 times y minus 5. I'm going to FOIL, so I'm going to get 3y squared plus 6y minus 4y is plus 2y. -4 times +2 is -8. On the other side, I'm going to get y squared. -5y minus 2y is -7y. -2 times -5 is +10. I'm going to move everything. So in this question, I can't isolate for y. There's not a single y. So we have to move everything over to the other side. I'll get 2y squared. +2y plus 7y is +9y. -2 minus 10 is -18 is equal to 0. Bless you. And then we have a complex trinomial, so we're going to factor it. So you'll get 2y and y. How about 6 and 3? Does that work? +12 minus 3. That should work. And our answer is going to be y is equal to 3 over 2, and y is equal to -6. Let's pick, we're just going to go straight to the slightly more challenging ones. Let's do question 18 and actually let's do questions 17 and 20. Quite a lot with binomials. I like, we'll do 18 and 20. So for a question like this, we have y over 2 minus y over 8 is equal to 2 over 3y. What I'm going to do to solve this is you need in order to cross multiply, you need one fraction is equal to only one fraction. But here we have multiple things. So I'm going to pair these together. I'm going to try and find a common denominator for them and group them together so I have just one fraction. And if you notice, you have a 2 and an 8. So to find a common denominator will be pretty straightforward. We just need to multiply the y over 2 by 4 to get that common denominator of 8. So let's do that. We're going to basically multiply this by 4 and multiply this by 4. And we're going to get 4y over 8 minus y over 8 is equal to 2 over 3y. Common denominator, so we can add the numerators. 4y minus y is just going to give us 3y over 8 is equal to 2 over 3y. I'm going to cross multiply, so we're going to get 9y squared is equal to 16. This is interesting because we don't have just a y by itself. We have a y squared. But if I move the 16 over, what kind of question does that give us? Sarah? Difference in squares, yeah. So when I move this over, I'm going to get 9y squared minus 16 is equal to 0. And it's just a difference of squares. So we're going to get 3y plus 4, 3y minus 4 is equal to 0. So in this case, y is going to be equal to negative 4 over 3, and y is going to be equal to 4 over 3. That makes sense? Pretty straightforward. Do you guys cover this in grade 10? You've never done this. Okay. Last question, question 20. Last question, and I want to tell you one other trick. Question 20. Now, question 20 is definitely the most challenging because take a look at it. It's 11 over 4x minus 4 minus 2 over x minus 1 is equal to x over 8. We don't have a proportion. We don't have just one fraction equal to another. However, if you take a look at this question really carefully, you almost feel like you can start doing something to this side. Does anyone notice something you could possibly do to try and solve this question, Marzu? Exactly. So if you recognize that this fraction right here, or this denominator right here is actually just 4 bracket x minus 1, to make them common, if you multiply the second fraction by 4, you will end up getting 4 bracket x minus 1, and then they'll be the same. So that is what we're going to do. Now, how do you notice that? Honestly, you just have to do a lot of questions to be able to practice seeing that. So this is going to be 11 bracket, and I like to factor as I go. So it's just 4x minus 1. I'm going to multiply the top and the bottom by 4. So this will be 8, and then 4x minus 1. And then we just have an x over 8 all by itself. Okay, 11 take away 8 is just going to be 3. Now, really, in this question, we don't have to have it in factored form. We could redistribute it to just be 4x minus 4 is equal to x over 8. Everyone follow how I did that? I found a common denominator, then I just subtracted 11 by 8, and now I'm going to cross multiply. So 8 times 3 is 24. The other side, it's going to be x times 4x minus 4. And this is going to give me a trinomial, which then I'm going to factor. So I'm going to just move stuff over while I do this. To factor this, hopefully you guys recognize that you can factor out the number 4, our greatest common factor. And then it's just a simple trinomial. So when I factored, I get 4 bracket x minus 3 and x plus 2. And so that means our solutions are x is equal to 3 and x is equal to negative 2. Okay, so here is, it's not even a trick. It's just something that will be very helpful. Let's say you have a question like this. I'm just going to make it up so it might not make sense. X over 5a plus 2 minus 3 over 5a plus 2 is equal to 7 over 5a plus 2. When you have a bunch of rational expressions that have the same denominator, what you can do is you can rewrite this question without any of the denominators. You can get rid of all of the denominators. So this question is essentially the same as x minus 3 is equal to 7. Why does that make sense? Well, when you have an equation, remember how we can multiply by the magic number to get rid of our fractions? Like, remember when we had something like 1 over 6x plus 2 over 3 is equal to 1 over 2, I could multiply everything by 6 and get rid of the fractions, right? This would become an x, this would become a 4, this would become a 3. In the same way, when you have something like this, you can multiply everything by 5a plus 2, and it disappears everywhere, and all you're left with is just the numerator. So I notice when you're doing some questions, especially in the textbook, this little trick becomes very handy. If you can try to get all the denominators to be the same, you can just cancel them out, and then all you have to do is the numerator. So, all right, so for this question, we have v minus 1 over v plus 7 is equal to 3 over 5. Whenever I have a binomial, I tend to keep it in brackets. So basically what I'm doing is I'm going to multiply 5 times the entire bracket of v minus 1 and 3 times the entire bracket of v plus 7. Our first line is going to look as follows. It'll be 5 times v minus 1 is equal to 3 times v plus 7. If you switch these around, like if you had the v plus 7 on the left and the v minus 1 on the right, that would be fine as long as you're multiplying by the right number. Okay, and now this is just back to grade 9. We're going to distribute. We're going to move our v's to one side, our numbers to the other side, and we're going to solve. So this will give me 5v minus 5 is equal to 3v plus 21. 5v minus 3v is 2v. 21 plus 5 is 26. We divide both sides by 2, and we end up getting number 13. And that's it. Now, in my other class, I started stating restrictions, and then I realized we don't need restrictions. We just solve for what v is. So the only number that v can possibly be is 13 and nothing else. So for these questions, you do not need to state your restrictions. You just need to solve for whatever letter they're asking for. Did this make sense? Questions? Okay, let's go on to question 8. Actually, let's go on to question 10. Okay, so for question 10, we're going to cross multiply again. We're going to get 3p times p minus 3, all in brackets, is equal to 2 times 2p plus 5. We will distribute. So we'll get 3p squared minus 9p is equal to 4p plus 10. Okay, now this question's interesting because can we isolate for the letter p? Like by moving things to one side and moving everything else to the other? The answer is we can't because we have a p squared and a p, and that makes things complicated. So instead, what we're going to do is we're going to move everything over to one side, create a trinomial, and then we're going to factor it to figure out what our p's are. So anytime you end up with a situation where you have a p, like a letter squared and another letter, that is your cue that you need to move everything to one side, create a trinomial, and factor. Okay, so this will be 3p squared. Negative 9 minus 4 is negative 13p. Positive 10 moved to the other side is negative 10 is equal to 0. And whenever you have a trinomial and you're trying to solve for p, we factor it. And once you factored it to solve for the letter p, it's kind of like when we were stating the restrictions, the same concept. You're going to take each bracket, you're basically setting it equal to 0, and you're solving. You don't need to show any work for this. You can just do it in your head. So for p minus 5, the solution would just be P is going to be equal to 5? And I'll just show you the work one time when the bracket is a little bit more complicated. So you're basically just doing 3P plus 2 is equal to 0. You see that? I'll move the 2 over to the other side. So 3P is equal to negative 2. I'll divide both sides by 3. And so my answer is going to be P is equal to negative 2 over 3. So that means there are 2 answers to this question. Kind of. They're talking about like which one of the answers will not make sense, but we'll just count all of them. Before we move on to the second part, let's do one more. How about let's try question number 9. Question number 9 looks pretty good. Okay, so why is this question different than the other ones? Well, this time we don't actually have a proportion. A proportion has to be one single fraction is equal to another single fraction. But here we have like complicated something is equal to a single fraction. So what we're going to do is we're going to clean up one of the sides so that we only have one single fraction, and then we'll do the proportion stuff. Question 17 is pretty straightforward because you have the exact same denominator, right? You have g plus 2 on both sides. So what we can do is we can just go ahead and add the numerators or subtract the numerators, and we're going to get g minus 2 all over g plus 2 is equal to 5 over g plus 4. Okay, so I recognize that my denominators were the same here, and I know I can just add the numerators. I'm just going to put it as g minus 2, and that's it. I recognize that you guys can't see this, so I'm going to change the color to be something a little darker. There we go. I don't know what just happened. Just going to rewrite this. So it's g minus 2 over g plus 2 is equal to 5 over g plus 4. Okay, now this is a proportion, so we can go ahead and cross multiply. And in this case, we're actually going to end up getting 2 binomials, so we're going to have to do a little bit of FOIL. So the first one I'm going to get is g minus 2 times g plus 4 is equal to 5 times g plus 2. I'm going to go ahead and FOIL the first 2 brackets. So I'll end up getting g squared plus 4g minus 2g is just plus 2g minus 8. And on this side, it's going to be 5g plus 10. If I move everything to one side, it's going to be g squared. Positive 2 minus 5 is negative 3g. Negative 8 minus 10 is negative 18 is equal to 0. And then we're going to factor. Alaikum assalam. Okay, so it's going to be G and G, minus 6 and positive 3. So our final answer is just going to be G is equal to 6 and G is equal to negative 3. Yeah, it's like the opposite. Did this make sense? Yeah, okay. 19 and then 20. Now that you guys are done, I'm changing it back to that really nice color because I love it. Okay, so let's take a look at question 19. Question 19 is interesting because, again, you have two fractions on the left side and one fraction on the right. Is there any way where I can make a common denominator out of 4 and 4a? What can I do to the first fraction? Kevin? I can just multiply the top and the bottom by a. So let's go ahead and do that. We're going to get a over 4a plus 1 over 4a is equal to 3 over 2a. Now, I was actually going to show you this trick later on, but I'm going to show you the trick right now. There is a little trick, which I actually wrote over here. Let me erase it so I can explain it to you one more time. Okay, so this is a little bit of a detour. When you have a question like I've written on the screen, so x over 5a plus 2 minus 3 over 5a plus 2 is equal to 7 over 5a plus 2. What you can do is you can actually rewrite this question where it's only the numerators. So you can write it as x minus 3 is equal to 7. And the reason why this is true is because remember when we used to have equations with fractions, and in order for us to get rid of the fractions, we used to multiply by the magic number. So if I had like 1 over 6x plus 2 over 3 is equal to a half, I'd multiply everything by 6, and I would end up getting this. Well, in this case, when every single denominator is the same, all you're basically doing is you're multiplying everything by 5a plus 2 and getting rid of all of the denominators. So this is kind of a trick. If you can try to make all of the denominators the same from on both sides of the equal sign, you can just make the denominators disappear and you just have to look at the numerators. Okay, so in this question that we were just working on, I noticed, well, we made the first fraction a over 4a, then we have 1 over 4a. Is there any way we can also make the fraction after a 4a? Well, what can we do? We can multiply it by 2. So let's do that. And when we do that, we get 6 over 4a. Now, technically, all of the numerators disappear. We're actually going to do it in both ways, the trick, and we're going to try to do it in the old-fashioned way. So let's try the old-fashioned first. I'm going to have a plus 1 over here over 4a is equal to 6 over 4a. I will go ahead and cross multiply. So this is going to be 4a times a plus 1 is equal to 6 times 4a. Okay, this will give me 4a squared plus 4 is equal to 24a. I'll move everything over to one side and I'll get 4a squared minus 24a plus 4. Hold on. Okay, so we solved it the old-fashioned way. I made a mistake. We found the mistake. And then we found out that a is equal to 0 and a is equal to 5. The shortcut is over here, if we recognize that all the denominators are the same, you can get rid of the denominator and you can just write a plus 1 is equal to 6. And then a is equal to 5. But you're going to notice this only gives you one of the answers. So you do have to be mindful of that. Once you do that, you have to recognize what you actually got rid of because that would be your other solution. So in this case, we made the 4 A's disappear, and that is where you would get your answer of A is equal to 0. Okay, so you can use any method you like, just keep in mind that that's one way to solve the question. Okay, that's all we're gonna do. I was gonna do question 20, but I'm actually gonna just leave the solution up here and you guys can try it because we still have quite a bit of time before we start our quiz. So go ahead and try question 20 yourself and see if you can get the same answer as I did. And then the homework is just the 2 sheets after. There are no textbook questions. Yep, this is the, I'm just gonna stop the recording.